Hi boys and girls, this is a video for those of you that missed school on Monday the 9th or Tuesday the 10th. And so what we are doing today is we're doing some percent proportion practice on page 20 and 21 of the Unit 3 packet. So make sure to turn to page 20 and we're going to get started here. So we're going to practice percent proportion today, and we're going to be using it in different situations for different types of problems. The first three are going to ask us to think about what numbers we're working with. So if we're going to use percent proportion, the first thing we have to do is kind of write it out. Part over whole equals percent over 100. That's always the first step. And then we think, well, what numbers do we have? Well, 60%, that's the percent. 60% of 300, any number after the of is going to be the whole. So if it said 60% of what number, we'd be finding the whole. But we have the whole here because it's 60% of this number would be the whole. We're looking for the part. So where it says part, I'm going to put a big circle. The whole is 300. The percent is 60. And the 100 is 100. Now this one seems to be straightforward. There's a one-step problem here. We can easily get from 100 to 300 by multiplying by 3. We'll do the same thing to the top. Multiply by 3. I know 3 times 6 is 18, so 3 times 60 would be 180. So that would be the part, 180. Here we have another problem, same numbers, but it looks like it's set up differently. 300 is 60% of what number? Well, I'm going to use percent proportion. Part over whole equals percent over 100. There's our percent. Now, notice the word of right here. It says of what number? We don't know the whole. That's what we're looking for. If we knew it, there would be a number after the word of, but we're looking for what the whole is if 300 is 60%. So that 300 is actually the part. So we're missing the whole. So 300 is going to be the part. The whole, we don't know. 60 is the percent. And 100 is the 100. Of course. All right, so again, we're trying to go from right to left here. How are we going to get from 60 to 300? Well, I know that 6 times 5 is 30. So I'm thinking that 60 times 5 would be 300. And then I'm going to multiply 100 by 5 as well. 100 times 5 would be 500. Now it makes sense why our answer is greater than the part, because this would be the whole. And so it's kind of like saying, well, 60% of 500 is 300. That's just another way of looking at that. Okay, let's try one more like this. So again, same numbers, but we might set it up a little differently. Part over whole equals percent over 100. 60 out of 300 is what percent? So it's clear we're looking for the percent, because that's what it's asking us to find. The 60 would be the part. If you notice the word of again there, that's the whole. The number comes after of is the whole. So to set this up, we know the part, 60. We know the whole is 300. The percent we do not know out of 100. Now this time we're actually going from left to right to find this missing number. 300 divided by 100, 300 divided by 3 would give you 100. 60 divided by 3 would be, well, 6 divided by 3 is 2. 60 divided by 3 is 20. So 60 would be 20% of 300. All right, so now that we get a little practice in there, we're going to look at some different situations, but we're still going to use percent proportion. The key thing about these top problems is notice that there's the same numbers, 6,300, 6,300, 6,300, same numbers, but we have different answers because in each problem, the numbers were a different part of the percent proportion. Here we had the percent whole, here we had the part percent, and the part and whole. So that's why it's really important to know what numbers you're working with, because your answer will change depending on where you put the numbers in the percent proportion. All right, so let's look at this first situation here. It says the original price of a 1992 Buffalo Bills AFC championship shirt was $44. The shirt was sold for 25% off the original price. What was the discount? All right, let's first, I'm going to write my percent proportion. Part over whole equals percent over 100. Let's think about what numbers we have here. Well, I'm going to start with the 25% because that's the percent. And then we'll think about this 44. Well, the 44 was the original price. So I'm thinking the 44 is the whole. That's the whole price. What we're looking for is the discount, which is going to be the part. So we don't know the part. We know the whole was 44. And the percent was 25 out of 100. Now, so it looks to me like we can't directly get from 100 to 44 easily. So we may have to simplify here. And I'm thinking, what can I divide 25 and 100 by? Well, 25 is one of our 9 numbers. So we can actually divide the top and bottom by 25. 100 divided by 25 will get us to 4, and then we can get from 4 to 44. So let's try that out. Let's divide by 25 on the top and bottom. And you get 1 to 4, or 1/4. Now, we can definitely get from 4 to 44 by multiplying by 11. And we can get from 1 to the mystery number also by multiplying by 11. 1 times 11 is 11. So what's the discount? It's $11 discount. It's pretty good. That sweatshirt would only be $33. That's a steal. All right. So if you want to try this next one on your own, you can. You can do it with me. It's up to you. So we'll put part over whole equals percent over 100. See here. Well, let's look at what we have. A pair of Bill Zubaz pants, a classic look, were sold with a 30% discount. The discount was $15. What was the original price? Okay, let's look at the numbers we have. We have the 30%. Obviously, that's the percent. The discount was 15. So I'm thinking that's the part. It says what was the original price? We're looking for the whole. So we have the part here. We're looking for the whole. We have the part. We have the percent. So the part, 15. The whole, we don't know yet. The percent would be 30 out of 100. Now, I'm feeling good about this one because we can easily get from 30 to 15. We can do that pretty easily by dividing by 2. We divide 100 by 2, and you get 100 divided by 2 is 50. What was the original price? $50 was the original price. Again, it's a fair price for Zubaz. I would take the $15 discount, but those are nice pants. Now, looks like we got a pair of Uggs here. A pair of Uggs were discounted by $9. This was a 15% discount. What was the original price? Okay, well, part over whole equals percent over 100. And then we'll think about what numbers we have. Think about those numbers. Let's see. We got a $9 here, and we got a 15%. Well, you know what? Let's start with that percent. That percent is clearly, believe it or not, the percent. The $9 is a discount. You're looking for the original price. Now, whenever I see original price, I'm thinking that's the whole. So the discount, of course, would be the part. Okay, feeling good about this. Feeling good. So the part is 9. The whole, we don't know yet. The discount would be 15%. And there's 100. Okay, now, oh boy. Looks like we can't get from 15 to 9 easily, so we may have to simplify. So what can we divide 15 and 100 by? What of the 9 numbers? Well, let's look at 15. I could divide 15 by 15, but that 15 doesn't go into 100. 3, but I can't divide 100 by 3. 5, perhaps 5. 5 is one of our 9 numbers. Let's do it. So let's divide by 5 on the top and the bottom. 15 divided by 5 is 3, which is good because I can now get from 3 to 9. 100 divided by 5 would be 20. 20. Now I can get from 3 to 9 by multiplying by 3. We'll do 20 times 3 is 60. So those Uggs were $60, but with a $9 discount, they'd only be $51. So $60 is the original price. So again, when using percent proportion, we have to first write down the little formula, and then we have to understand what numbers we're working with, whether we have the percent or the part, whether we have the whole or the part, or the whole and the percent. Once we know that and we set it up, then, sometimes we'll have to simplify. Sometimes we can get there in one step. I'm just going to go turn the lights back on. Okie dokie. So we're going to try a couple more of these today here. So let's flip the page here. All right. So all the items on the previous page were an outfit that I was thinking about, maybe perhaps wearing to the Bills game. It says, to complete the outfit, Mr. Lovering, which is me, went out to buy an elaborate hat. So there's the hat. On sale. Look at that. The original price of the hat was $30. The price of the hat was reduced by $12. What was the percent discount of the hat? All right. So part over whole equals percent over 100. It appears as though we're looking for the percent. It says, what was the percent discount? So we don't know the percent. So let's see. The original price was 30. I'm thinking the original price, that's the whole price. The price of the hat was reduced by $12. I feel like that's the discount. That's the part. So now we're trying to find the percent. What was the percent discount? Okay. So the part is 12. The whole is 30. The percent, we don't know, out of 100. Again, how are we going to get from 30 to 100? We can't do it easily. So let's think about what we can divide by. Can we simplify 12 and 30? You bet we can. We can divide them both by 6 would work. We can divide them both by 6, because if we divide by 6, we'll get to 5, and then we can get 5 to 100. But you know what? I'm gonna try 3. I think 3 might work too. If we divide by 3, because we can then get to 10, and I like working with 10s, and then we can easily get from 10 to 100. So I'm gonna divide by 3. You could divide by 5. You could divide by 6 if you want to get to 5. But 3 would also work. All right. 30 divided by 3 would be 10. 12 divided by 3 is 4. Brilliant. Now we can get to 100. So we're going to multiply by 10, because 10 times 10 is 100. And then we multiply the 4 by 10 times 10. 4 times 10 is 40. So that means the hat's discount was 40%. That's nice. That's a good discount on that fabulous hat. And a very elaborate hat. It has a little feather in it. I think it'd be perfect for a Bills game. Okay, so another 2-step one. Of course, when we reach a point where we can't get directly from one number to the other, we can always simplify. All right, we're going to check out a few of these problems below here. So we had let's talk about this one. Mr. Yoshi has 75 pretzels. He ate 60, and he had his son eat the rest. What percent of the pretzels did each person eat? Okay, I'm going to use percent proportion here. Part over whole equals percent over 100. Now, let's think about what we have here. He has 75 pretzels. He ate 60. I'm thinking that's the whole. That's the entire amount of pretzels he had. He ate 60, which is a lot. Go, Mr. Yoshi. Go, Mr. Yoshi. He loves those pretzels. All right. So we're looking for the percent. That's what we don't know. So I'm going to set this up here. Part is 60. The whole is 75. Equals, well, we don't know the percent. That's what we're trying to find over 100. Oh, boy. Now, we have to somehow get from 100 to 75, but we might not be able to do it in one step. We might have to simplify. What can we divide 75 by? Well, we can divide by 5, and we can divide 60 by 5. But if we divide by 5, we'll get to 15. We can't really get from 15 to 100. Now, I'm thinking, when I think about 75, I think quarters. I'm thinking quarters. If I can get to 25, we're in business, because then we can get to 100. So how can we get from 75 to 25? We divide by 3, because there's 3 quarters would be 75. So divide that by 3, you get 25 per quarter. 60 divided by 3, 6 divided by 3 is 2. 60 divided by 3 is 20. All right, we're almost there. We're almost there. So now we can get from 25 to 100 multiplying by 4. So we do the top as well. Sorry for the, it's kind of a thin path there. Multiply by 4. 20 times 4 would be 80. So Mr. Yoshi ate 80%, but it also says what percent did each person ate? And then Mr. Yoshi's son ate with the other part of the pretzels, which would be 20%, because 80 plus 20 would be 100. So Mr. Yoshi ate 80%. The son, that's a 2, not a Z, ate 20%. All right. Let's try a couple more here. So Mrs. Bennett has baked 20% of her 150 cookies. How many cookies does she still need to bake? I'm starting it off. Part over whole equals percent over 100. Again, the more we write it, the better we'll remember it. And it will help us set us up. It'll help us set up the problem. Mrs. Bennett has baked 20%. Well, you know what? That's the percent of her 150 cookies. How many cookies does she still need to bake? Now, you see that word "of" there. So I'm thinking this is the whole, because that's the total number of cookies she wants to make. We want to find out how many does she have left to go, which will be the part. She's made some already. She's baked 20%. We're trying to find out how many more does she need to bake. So we're looking for that part. We're looking for the part. Put a big circle there. The whole is 150, and that's 20%, 20 out of 100. Okay, can't directly get from 100 to 150. However, there's a few different numbers we can divide by, which is nice. We could divide by 4 to get to 25, and then we can get from 25 to 150. We could divide by 20 to get to 5. We could divide by 10 to get to 10, and then we can get to 150. I'm gonna divide by 2, actually, because if I divide by 2, you get to 50, and we can easily get from 50 to 150. So I'm going to divide by 2. But any of those other numbers would work as well. 100 divided by 2 is 50. 20 divided by 2 is 10. Let's multiply here. 50 times 3 is 150. 10 times 3 is 30. How many cookies does she still need to bake? Now, here's the thing. That 30 is what she did bake. How many does she still need to bake? The number she'd still need to bake would be, if you subtracted those, you get 120. She still needs to bake 120. So most people would probably say, oh, she needs to bake 30. But that's because that's 20%. That is the 20%. That's the number that's the baked number. This would be the answer. That's how many she still needs to bake. So Mrs. B, we'll call her, needs to bake. So that's when it's really important to understand what the numbers mean. That 30 is not how much she has left. That's how much she needs to still bake. All right, let's try one more here. We're going to try this one here about the 325 students at OPMS. 325 students were surveyed at OPMS about their favorite food. 16% chose nachos. How many students chose nachos? As my favorite food, maybe nachos, but that's a high percent for nachos. I'm surprised by that. So let's think about what we have here. Part over whole equals percent over 100. 325 students, and we have 16%. Well, the 16% is clearly the percent. That's the percent. 325 students were surveyed, 16 chose nachos. How many chose nachos? How many chose nachos would be the part. The 300 students that were surveyed must be the whole. So we're looking for the part. We have the percent, we have the whole. Okay, so we're looking for the part, big circle. The whole is 325. 16 out of 100, 16% out of 100. Now, again, just like the last two, or the last three actually, we can't get directly from 100 to 325. We're going to have to simplify. Now, let's see, what could we divide 116 by? Which of the 9 numbers? 5's not going to work. 10's not going to work. 25 is definitely not going to work. 2 might work. 2 might work. Well, no, 2 wouldn't work because then we get to 50, and we can't get from 50 to 325. 4 might work. Let's do 4, because if we divide by 4, we'll get to 25, and then we can get from 25 to 325. I'm thinking quarters. Here. Dividing by 4. 16 divided by 4 is 4. 100 divided by 4 is 25. All right, sweet. Now we can get from 25 to 325. Do the same thing up top. I'm going to do a little top in the box here. I'm going to do a little dividing to see how we can get from 25 to 325. So I'm going to divide. 25 goes into 3, 0. 25 goes into 32 once. 25. Subtract that. I believe you get 7. Bring down the 5. 25 goes into 75 3 times. And that, of course, you got 0. So that means you'd multiply by 13 on the top and the bottom. 4 times 10 is 40. 4 times 3 is 12. 40 plus 12. You could always do the work off to the side, but it would be 52. 52 chose nachos. Now, you could, of course, do the last one on your own. It might be a good idea to try that out, but I hope that we got some good practice in here with percent proportion. And if you have any questions when you come back, just make sure to let me know. Hope to see you soon. Bye-bye.